Hey, I'm Jay, your Moralis instructor from beautiful Finland. I got into crypto in 2020, and I've been building in the space ever since. In my free time, I enjoy running and at the gym, and in the summer, you'll definitely find me at the golf course. Now, let's get stuck in and learn about Web3.
What is up, everyone, and welcome to this week's Moralis project, where you're going to build your very own decentralized autonomous organization where members of the organization are a set of NFT holders. This could, for example, be our Moralis Hall of Fame NFT holders, which is essentially previous project builders. But you could use any NFT collection you'd like, just modifying the code. So how we're going to build this, you're going to write your own underlying Solidity smart contract for the Decentralized Autonomous Organization. You're going to deploy and verify this smart contract using Hardhat. And then you're going to build this wonderful user interface using React and the Web3 UI kit. And of course, connecting everything is Moralis, which will connect your smart contract's details to this DAO so you can interact with your smart contract and pull data from your smart contract to present in this front end. So how cool does this look? We get details about past proposals, the pass rate, how many proposals have been created, the number of NFT holders / DAO members, ongoing proposals. We don't have any at the moment, and we see all our past proposals. We can go look at one of them. So for example, should we accept Elon Musk's $44 billion offer for our DAO? Of course, we're not going to accept that. We got 2 votes for this proposal, 1 vote down and 1 vote up. We can't vote for it anymore because we didn't get a majority votes for this proposal. It was rejected. Now, going back to the overview page, let's go ahead and create a new proposal. So first you have to connect your wallet. Make sure you connect with a wallet that has an NFT that allows you admission to this DAO. And this is one of them. So then you create a new proposal. Should we create an Elden Ring Web3 tutorial? Let's submit this proposal, accept it with MetaMask. And as this contract interaction went through, so did our overview page update with an ongoing proposal, which we can now vote on with members of the DAO. So if we go over here, we can see the status is ongoing. There have been no votes yet, but because we as a member can vote on this proposal, let's vote for, let's submit. We do another MetaMask interaction, we confirm, and now it went through and we got all this detail for our proposal. Votes for 1, votes against 0, and the account we're just logged in with voted positively for this proposal. We can even try doing this with an account that doesn't hold an NFT. So let's go on account 5 over here. And using this account, let's try and vote against. We're a malicious hacker. We get an alert. You are not able to vote on this proposal because you don't have an NFT. So how cool does this look? You're going to build all of this today. And let's even look at Polygon scan over here. This is our smart contract. We 1 minute ago created a proposal, and 56 seconds ago we voted on a proposal. We get events emitted as well. We get this vote that was emitted, and we get this create proposal that was emitted. And all this data can be synced to Moralis. So if we open up a Moralis database, look at this, proposal 4 was just created. The description, should we create an Elden Ring Web3 tutorial? If you're excited for this build, stay stuck in and let's learn how to build your very own decentralized autonomous organization. Rightio, before we get into any of the code, if you're a beginner, I heavily suggest you go ahead to the testnet.opensea.io, connect your MetaMask wallet, and go ahead and create a new collection over here. Go through these steps and create a collection on the Mumbai testnet, and then go ahead and press create over here, add a image, video, or audio file, whatever you want to mint as an NFT, and add it to your collection that you just created, as this will help you tremendously going through this tutorial and you won't have to tweak any of the code itself. Also remember to use the Mumbai testnet blockchain. All right, let's get into it. Okay, so let's get going over here. What I have open is an empty folder called DAO in Visual Studio Code over here. And we'll go ahead and create our smart contract that will handle our decentralized autonomous organization. So in the terminal over here, you can create a directory called smart contracts and then cd into that folder. Now in this folder, we'll want to initialize our Hardhat project and install a few dependencies. So go ahead and do npm id Hardhat. And with Hardhat installed, we can initialize a Hardhat project by running npx Hardhat. And then press create a sample project. Yes, yes, yes. And it will go ahead and create it for you. Beautiful, beautiful. So here in our file directory, if we open up smart contracts, it is filled up with a Hardhat sample project. But first, let's install the last few dependencies. So you can clear the terminal and run npm id.env. Clear the terminal again and run npm id at nomic labs/hardhat-etherscan, like so. So now we have our sample project set up and all the dependencies we'll need, so we can clear the terminal and go ahead and start working on our contract. We can go ahead and get started by jumping into this contracts folder, and we find this greeter.sol file. The SOL stands for Solidity. So what we can do is we can get rid of this sample Solidity smart contract and even rename our contract to say a capital D DAO.sol, and then define the license we're going to use and the version of Solidity at the start of our contract. So we'll be using the MIT license and Solidity 0.8.7 and above. And then go ahead and create your contract by running contract Moralis DAO and then squiggly brackets. And inside these squiggly brackets, we will write our contract's functionality. Save that, and let's go ahead and start by initializing a few variables. Radio. So first of all, we want to store the owner of the smart contract in a publicly viewable address variable, so anyone in the community or the blockchain space can view who the owner of this DAO is. Then within the smart contract itself, we'll keep track of the next proposal's ID. So every proposal that the community of the DAO puts forth will have a uniquely identifiable ID. So we just have to keep track that what the ID will be so that this can be set for the next proposal. And then of course we need to have an array that distinguishes which tokens are allowed to vote on this DAO. So the valid tokens, this could be ERC20 tokens as well, but in this case we'll have the token ID numbers that will allow users of the DAO to make votes and proposals on this smart contract. But to make sure that any address actually owns any of these valid tokens that gives right to vote in our DAO, we need to make an interface to the smart contract that created these NFT tokens, which keep track of the balance of any addresses that hold these tokens. Let me show you what I mean. So here on the testnet OpenSea, I've created this sample NFT project called Moralis Bidlers, and I hold 15 of this number 1 NFT. And we can see that the contract address is over here, and we have our token ID as well. So if we copy this token ID and go to the contract address, it takes us to Polygon Scan, and we see that this is the OpenSea storefront. If we go to the contract section and the read section on the contract, we have this function called balance of. And we can take our token ID and then take our wallet address from over here in MetaMask, paste it over here, and when we query, we get the balance of our wallet for this token ID that I showed you over here. So we get that 15 token balance. So this means we need to use this function from this smart contract over here to be able to identify in our smart contract that a user actually has our tokens. So let's create that interface at the start over here. It'll go outside our contract like so. So we call it interface DAO contract, and it just replicates the function that the OpenSea storefront has. So it's the balance of, it takes two parameters, an address and a UN256 number, and then it returns a UN256, the balance of this address for this token ID. And now in our variable initializations, we want to create a reference to this interface like so. So now our DAO contract variable will actually run this functionality, but in our constructor, we still have to identify what is the smart contract address to use for our DAO contract interface. That's a mouthful, but let me show you constructor and you'll probably get a better idea of what's going on. Okay, so underneath our variable initializations, let's create a constructor function. So the functionality that will be run at initialization of this smart contract or deployment of this smart contract. So what we'll have is we'll set the owner to the message sender. So whoever deployed the smart contract will become the owner of this DAO smart contract. The next proposal, so the first proposal that is created, will have an ID of 1. And then every time we create a new proposal, we'll just increment this next proposal variable to get the ID, the next ID. And then for our DAO contract, so we take the iDAO contracts interface and make sure that we use the smart contract for the OpenSea storefront on the Polygon Mumbai testnet. So this makes sure that anytime we call this DAO contract, we can use this balance of function from that smart contract. So in our smart contract, effectively, we're using another smart contracts functions when we call DAO contract balance of. And then for the valid tokens, which is an array of the tokens in the OpenSea storefront smart contract, we initialize it to just have this one token ID, which is, you guessed it, this Moralis Bidler NFT. So this makes sure that when we're creating a proposal or when we're voting, we make sure that the wallet address that's trying to make the vote or proposal actually holds this NFT in their wallet from this smart contract. So that's our constructor, and then we can go ahead and define a few structs that define the structure of a proposal and stores the data for each of our proposal. All right, so let me just create it over here and then let's talk you through it. So a struct is effectively kind of an object that stores different variables. Then we can say have multiple of these proposals mapped in a mapping to store all the different proposals on our smart contract. But for our proposal struct, we store the ID. So this next proposal ID will always be stored in the next proposal that is created. Then we have a Boolean, which declares whether this proposal actually exists. So if someone searches for a proposal of 5 and we haven't created proposal 5, this proposal won't exist. And that will help for our require statements. Then we have, of course, the description of the proposal. So say what we want to propose. Should we have McDonald's or should we have Taco Bell for lunch today? Then our deadline, which will be a block number distinguishing what is the deadline to cast your votes if you have one. So that makes sure that proposals don't just last indefinitely, but they have a structured time when you have to cast your vote by. Then, of course, we can follow the total number of votes up and total number of votes down for our proposal. So these can be incremented even after this proposal is created. Then, of course, we'll have an array of addresses, which will be the wallet addresses that actually hold these valid token NFTs. So we'll be using this balance of function for our DAO contract functionality to create this array of addresses that can actually vote for this proposal. Then the max votes will just be the length of this address array. And then we create a mapping which gives us the voting status of any possible address, which is set to a true or false. So even if you're in the address array for can vote, if you've already voted, we'll modify your vote status to true so you can go ahead and vote multiple times on the same proposal. And then finally, we'll have 2 Booleans for when the time limit, the deadline has passed. The owner of this DAO smart contract can count the votes that are cast for any proposal, and then we will change our past Boolean to true if there were more votes up than votes down, but if there weren't more votes up and more votes down, only the count conducted Boolean will change to true, and our past will stay as false. So that is all the information we'll need to store for any of our proposals. And of course, because the idea of a DAO is a decentralized autonomous organization, that anyone can view, these proposals will be public. So making all the proposals stored on the smart contract public is very simple. We just have to create a mapping over here at the bottom. So this mapping maps any UN256, so essentially a proposal ID to a proposal struct, and we call it public, and this mapping is called proposals. So now, anytime a proposal is created, we'll want to modify the exist parameter to true, and then fill in all these details for that proposal struct, and it will be stored in this mapping for anyone to view. And then for future reference, when someone makes votes, we can modify these parameters, and when someone counts the votes, we can modify these parameters, etc., etc. And now before we go ahead and create our actual functions, let's create a few events that we can emit in our functions and then listen to with Moralis in the end, which means that when new proposals are created or new votes are cast, these events are automatically synced to our Moralis database, and then we can present that data automatically to our users through our Dapp. How cool does that sound? So let's create our first event, which will be creating a proposal. So we'll call this event proposal created, and all that emits is 4 variables: the ID of the proposal that was created, the description for that proposal, how many wallet addresses can vote in that proposal, and then the proposer. So because the point of a DAO is that anyone part of the DAO can propose anything, we want to keep track of who is making the proposals as well. Now for our next event, we'll call it new vote. So this takes in 5 variables, and it emits the current number of votes that are up, the current number of votes that are down. So this will help us calculate the current status of the voting for a proposal. Then we'll keep track of who made the most recent vote, on what proposal they made the vote on, and then finally, did they vote for or against the proposal? We'll just store this in a Boolean. So if it's true, the user voted that they are for this proposal, and if it is false, they voted against. Simple, simple stuff. And then for our final event, so like I said before, the owner of the smart contract, by the deadline or after the deadline of this proposal, count the votes of that proposal, and then it'll automatically update the proposal to be accepted or rejected. So we would just want an event, a simple event, that when the owner calculates the votes for a proposal, we get the proposal ID and whether this proposal was passed or not, and then we can present this in our Dapp nicely to the users, telling them that, okay, this proposal was rejected or this proposal was passed, and move it from the ongoing state. And now we're ready to start creating our functions. Coolio. So for the first two functions, we'll create functions that are only applicable for this smart contract. So in technical terms, they'll be private functions. Let's create the first one over here that will check the proposal eligibility. So this means that if someone is trying to create a proposal, we'll use this check proposal eligibility function to use it as a require statement for the creating proposal function to check whether that user actually owns any of the NFTs that makes them part of this DAO and allows them to make proposals. So let's look at this function. It takes in one address, so the proposalist, whoever is trying to make that proposal. And like I said, it's a private function that returns true or false for us. Now, all this function does, it creates a for loop that runs through all the valid tokens. So like we said, set over at the start over here, we set our valid tokens to only have this one token. At the moment, we'll create a function where the owner of the smart contract can add new tokens to the smart contract, effectively increasing the pool of people who are part of the DAO. But for now, we only have this one NFT token that grants you access to this DAO. And after we loop through all the valid tokens, we check using our DAO contract function, which is the interface to our OpenSea storefront smart contract, we check whether the proposalist holds any of the valid tokens. And if they do, we return true for this check proposal eligibility function, and otherwise we return false. So all this function is doing is checking using our valid tokens array list and the OpenSea storefront smart contract to check whether the wallet that is trying to make a proposal is a part of our DAO. And with that done, we can move on to our next private function, which will be checking whether a voter can actually vote on a specific proposal. And this is a private function as well that returns true or false, so it can be used as a require statement. So similarly, we create a for loop, but this time we loop around a specific proposals in our proposals mapping. So we get the proposal by passing the check vote eligibility function, the ID of the proposal. And then we get the can vote array and its length, so we can loop through every element or address in that can vote array. And then if the voter that we pass into the function as well is present within this can vote array, we return true. So they are a part of the pool of addresses that at the time of creating that proposal held one of the NFTs, now can vote on this proposal. And otherwise, if they're not in this can vote array for that specific proposal, they will not be allowed to vote and will return false when creating our vote function. This is beautiful stuff. Now we can go ahead and create our first function to create an actual proposal into our smart contract. So this will be a public function over here. So a function, let's close this so you see it a bit better. Create proposal is a function name, and it takes two parameters, the description for that proposal and then an array of addresses that can vote on this proposal. We do this because when we have the Dapp, we'll actually use the Moralis Web3 API to get the current status of holders of the NFT as for this parameter. But see, it's a public function, so anyone can call it as long as they pass the require statements. And talking about the require statements, we can paste it in here first, like so. So we require that this check proposal eligibility function over here returns us true for the message sender. So all we're doing is checking that the message sender actually holds one of the NFTs we've set in the valid tokens array. And if they don't, we get an error message saying only NFT holders can put forth proposals. Now for the functionality of this function, we want to create a new proposal in our proposals array. So taking the next proposal index, which will be 1 at the start, and then after this function we'll increment this to the next full digit. But so in the start we'll have the proposals for index 1. We'll create a temporary new proposal and fill this in with the data we want. So the ID, of course, will be the next proposal. We'll change the exist parameter to true. Then the description we pass in the function call will set as the description for this new proposal. Then the block number will say that the block number that we currently are at plus 100 blocks. You could change this to whatever you like, or you could even have the function call set how many blocks this vote will go on for, but that will be set as the deadline for this for voting to go on for this proposal. And then for the can vote array, again, this is passed in the function call, and then the max votes, this will just be the length of that array. So now we have a new proposal created in our proposals mapping that can be publicly called by anyone. And after that, we also want to emit an event on the smart contract so we can read this new proposal being created through Moralis. So let's create that emit event here. So like you remember, the proposal created event emits the proposal ID, the description for that proposal, the maximum votes for that proposal, and who proposed that proposal. So that will be the message sender, whoever's interacting with this function. And then at the end of this function, because we won't want duplicate proposals, we'll want to increment our next proposal variable. So just copy that and add 2 pluses there. And that's great. You've created your first function to create a proposal on this smart contract that only people with an NFT at the moment of creating this proposal are allowed to vote on. And your DAO is ready to go. And now we can start creating the functionality for casting a vote on this proposal. Starting it off here below our function, create another public function called vote on proposal. And this function takes as parameters 2 variables, the ID of the proposal we want to vote on and our vote. True meaning we're for the proposal and false meaning we're against the proposal. And this function, to be able to run, will need to have quite a few more require statements to make sure that we don't vote on the wrong proposal or malicious people can't vote on the proposal multiple times. So let's create our require statements over here, or require statements in total. So the first one, we'll just check that in our proposals mapping, the proposal we're trying to vote on, it actually exists. So you remember here when we're creating a proposal, that's when we set the proposal exists Boolean to true. So now when we're trying to vote, we just make sure that it exists. Otherwise, we'll say that the proposal doesn't exist. Then we use the check vote eligibility function to just make sure that the message sender, so whoever's trying to interact and vote on a proposal, actually is in the proposals can vote array. So if they're not, you can't vote on this proposal. Then the voting status. So although you might be in the can vote array, if you've already voted on this proposal, your vote status will be changed to true, so you can't vote multiple times. You'll see that functionality being added here into this function itself. And then of course, for the deadline, we'll want to make sure that the current block number on the blockchain we're going to be on the Mumbai testnet, isn't higher than the deadline set when creating that proposal. So you can only vote for the period of time that was set when creating that proposal. So that's our require statements. Let's go ahead and add the voting functionality. Now this is as simple as getting an instance from our proposals mapping of the proposal we're trying to make our vote on and checking whether our vote is true. Then we increment the votes up by 1, and if it's not true, if it's false, we increment the votes down by 1. And similarly, for our vote status that I talked about earlier here, we set the vote status for the message sender to true. So this will allow us to catch this message sender who's trying to vote on this proposal again in this require statement so as to not allow them to vote multiple times on the same proposal. Now lastly, we also want to emit the event on a new vote being cast so we can read it in Moralis. So that's just a case of emitting the new vote event, which tells us the current status of the proposal that was voted on, its votes up, its votes down, the wallet that cast their vote, and then of course the proposal they casted the vote on and which direction they voted. Did they vote true or false? And now, last 2 functions will be just for the owner of the smart contract. So when these proposals are created and the deadline has passed, we want to be able to count the votes to see whether this proposal was passed or not. And then also we want to have a function that can add new valid tokens into our smart contract if we want to have new DAO members that hold different NFTs in the future. All right, so for counting the votes, let's just create this function called count votes. All it takes as a parameter is the proposal we want to count the votes for. Now for the require statements, again, we have 4. So for the first one, we want to make sure that the caller of this function is only the owner. So not just anyone can go ahead and start counting votes. We have to have some structure in our DAO. Then we also make sure that the proposal we're actually trying to count exists. But this time for the block number, we make sure that the current block number is higher than the deadline. So the owner can't even count the votes before the deadline has passed, making sure that the owner can't do anything malicious. And then because in each proposal we keep track if the count has been conducted, if the count has already been conducted, the owner doesn't need to conduct it again, and we're catched in this final require statement. Now for the functionality, very similar to our voting, we just get an instance from our mapping of proposals of the proposal we're trying to count, and then we check if the votes down is less than the votes up. So if we have an over 50% vote rate, we change the passed parameter in our proposal to true. So this proposal has been passed. And then otherwise we keep it as false. And then nevertheless, whatever the result of this if statement is, we change the count conducted parameter to true. So this proposal can't be counted on again. And then again, to be able to listen to this on Moralis, we emit our event, which is simply just our proposal count, which is the ID of the proposal we're counting and whether it passed or not. That was very simple. And now let's create our last function to add valid tokens if we so desire. So the simplest function of all, just a simple public function that the only required statement is that you're the owner, so only the owner can define which tokens are valid and give voting rights in this DAO. So all we pass is the token ID we want to add, and then we push this to the valid tokens array. And that completes your DAO.sol Solidity file. We save that, and we can go ahead and head over to using Hardhat to configure and deploy this smart contract. What I'll have you do is open up the file directory again, and you see the scripts folder over here. This will be our deployment script, so you can remove all the comments. We don't need those anymore. And that should be good. So let's rename the script to deploy DAO. And now in our script, we have all these greeters over here, but because we changed our contract to DAO, we can change all the greeters to DAO. So do a control find and put it to case sensitive. Wherever we have greeter, we change those to DAO. And change all of those, that will change 4. And then do the same thing, but for the lowercase greeters, greeter like so, and change them to lowercase DAOs. And that will have your deployment script pretty much ready. The only thing is, because we didn't have any constructor arguments, we can remove this hello hardhat string from over here, and that will be ready. Your deployment script is ready, and we can move on to the configure file over here, hardhatconfig.js. One thing I realized though, that go back to your DAO.solidity file and change your contract name from Moralis DAO to DAO, just to make sure that we're keeping the same naming convention like so. So now all the DAOs that we have in our deploy DAO script will work seamlessly. So back to the hardhat.config file. Here at the beginning, we'll have to require some libraries we're going to use. So the libraries are Nomic Labs Hardhat Etherscan. This will allow us to verify our smart contract. Then of course .env, where we'll store all our variable keys for deploying and verifying our smart contract. So speaking of that, we can go ahead and create a file called .env in our file directory over here, where we'll put the keys that we need for compiling, deploying, and verifying. Right, so the keys that we're going to store in this environment file are the API key for Polygon scan, so we can verify our smart contract. Then a Polygon Mumbai node endpoint, so we can talk to our actual blockchain. If you want to use a different blockchain, you can do that as well. And then the private key for your wallet address that you want to use to deploy the smart contract and become the owner of the DAO. So let me just show you how you can get all these. So if you remember, we have our Polygon scan open with the Mumbai testnet. Here, go to mainnet over here, and then you can log into your account. When you go to your profile, you have this section about API keys, and you can add an API key. Let's call it DAO. And you'll be able to create your own. Don't use this one because I'll be deleting it before this video comes out. But then you can copy this API key, go back to your env file, and add it to your API key section over here. Let's save that for now. And then heading back to our browser, let's go to moralis.io. So this is your one-stop place for everything Web3, which also gives you speedy nodes. So go ahead and log in. After you log in, you'll come to your server page, but you'll want to go to your speedy nodes over here. Select the Polygon network and look at the endpoints. And because we're not deploying on the mainnet, we're deploying on the Mumbai testnet, you want to get this URL from over here. This is your endpoint to the Polygon Mumbai testnet that we can paste in over here. And finally, for your private key, I'll show you how you get it, but I won't paste it in here because it's just good practices to never slip out your private keys, even if it is a test account. So go to your MetaMask. We have account 1 over here. We'll use this one. Press these 3 dots over here, look at your account details, and then you'll have a chance to export private key. So by pressing this, you'll get access to your private key, and then you can paste it into your .env file. This is your public key. And then you'll just want to paste the private key over here and move on back to your hardhat.config.js file. Now here in hardhat config, because we already brought in the libraries we need, all we have to do is change this module exports object over here at the bottom. I'll just paste what we need. So it's an object that defines the Solidity version we're using, 0.8.7, and then the network, which will be Mumbai in our case because we're deploying on the Mumbai network, and we get the endpoint for our Mumbai node, and then the account's private key in an array format that we're deploying this smart contract with. And then for the case of verifying our smart contract, we have to have this key called etherscan, and in that object we have an API key where the value is the API key we got from Polygon scan. So now if we save that, we should be ready to start deploying our smart contract. So open up the terminal nice and wide and let's get started. The first command will be npx hardhat clean. Then for the next command, same thing, but rather than clean, we'll do compile. And you should get a message saying one file successfully compiled. Now to run our deploy script from our scripts folder, you're going to have to write npx hardhat again, run scripts / the name of our script, deploy DAO.js, and then define the network Mumbai. Press enter. And this may take a while, but afterwards you get this very clean line, DAO deployed to, and then this is your smart contract address for your DAO. So we can go check this out right now. Copy that for you, head back to your Polygon scan and search for that address. Of course, now we're on the main NetBlock Explorer, so I have to change to testnet from over here, and here search for that same address. And look at that, contract creation 1 minute ago, the wallet that we used to deploy it, but we don't have access to the contract yet because we haven't verified it. But we can do this very easily with Hardhat because we've set everything up. So just jump back in your terminal, write npx hardhat, verify, then your smart contract address, which you have copied into your clipboard already, and choose the network again, network Mumbai. Press enter. And after we let that run, we get nothing to be compiled, but we submitted successfully our smart contract for verification. And then after a while, it came back as verified by Etherscan, which in turn means Polygon scan. So we can go check out our smart contract over here. We haven't refreshed the page, so let's refresh the page. And we get that green tick mark showing the smart contract that we wrote during the first part of this tutorial. How cool is that? We have a verified smart contract, and we can use the read contract functionality to get the owner, the valid tokens, the proposals, and then we can write the contract to add a token ID, count the votes, or create a proposal, or even vote on a proposal. How cool is that? We'll go ahead and play with this smart contract a little bit before we go ahead and jump into creating that front end for this Dapp. Let's get going by connecting to Web3 first, using MetaMask over here. And now we're connected to this account that deployed this smart contract as well. And this is important because we know that this account actually holds this NFT that is important for voting or casting proposals on this smart contract. So if we go ahead and go and try and create a proposal, we should be able to do this because we hold this NFT. Let's give it a description. So this will be something that we want other holders of this NFT to vote on as well. So let's just say, should we start a burger joint? Like so. And then the can vote. Because we don't have Moralis Web3 API for this, we have to still put manually an array of addresses that can vote on this. But we can go over here to OpenSea and see the owners of this NFT over here. And we see all these addresses, so we can copy them and paste them into our input field on Polygon scan. Like so. So here we have the 4 addresses. We had to do this manually, but when we actually create that front end for the Dapp, you will see that when we connect to Moralis, we can easily get these addresses using the Moralis Web3 API. But now, if we try and write this function, MetaMask pops up, asks us, do we want to do this contract interaction? We confirm. The contract interaction is pending. We'll wait for that to go through, and it is complete. Now, if we go ahead and try and read this smart contract, read for proposal 1, because this would have been the first proposal we created, we query that. Look at that, we get our first proposal 1. It exists, true. Should we start a burger joint? And the deadline will be this block over here, which is 100 blocks from now. We don't have any votes currently, 0 votes up, 0 votes down. We see that there's 4 people who can vote on this proposal and the count has not been conducted yet. But now we can ourselves go and vote because we have an NFT. We are allowed to vote on our own proposal. So let's vote on proposal I. And we of course want a burger joint. So we vote true. Let's write that and confirm. Wait for our contract interaction to go through. It's gone through. And now if we go read our contract and update our query, we have one vote up. And if we were trying to do a vote again, we should be caught by our require statement. So if we try and vote on the same proposal, we would get an error because we have already voted on this proposal. But now let's try and go on a different account. So change your Web3 account over here. So now we're connected on this different account and we won't be able to do the same things because we don't actually hold an NFT on this account. So if we try and go and vote on, say, proposal 1 and say false for this, right? We would be caught by an error because we don't hold that NFT token. We can't vote on this proposal. But let's go back and go on a different account. So say account 2 over here that does hold this NFT, like so. So now we're connected to our account 2 that does hold this NFT. You see that over here, 0x5D. And now try and go vote on this proposal. Let's vote on proposal 1 and we'll vote true as well. And right. We don't get any error messages and we can confirm. Wait for the contract interaction to go through. The contract interaction has gone through. We can go read the contract again, query our proposal 1, and we see that we have 2 votes up right now. If we try and query for proposal 2 over here, query for that, there won't be anything because we haven't created another proposal. Now, one last thing, if we go and write our contract and try and count the votes. So only our owner of the smart contract or the deployer can count these. So we have to go back to our account 1, like so. So account 1 is connected now, and we try and count our proposals for proposal 1. We would be caught by an error because the current block number is still below the deadline of voting. So we can't vote until the deadline has passed. So we reject that. And let's just wait for a while. Go to read contract, look at our proposal 1 again, query. The proposal deadline will be 926. Is the deadline. So if we look at the current block number, view blocks, we are at 850. So we have to still wait for a while. Let's wait for a while and I'll update this when we are past that 926. Rightio, so I have a little break from recording, now came back, and it seems that our current block has now exceeded our block ending 1926 and is now 2133. So we can head back to our contract. So this is the contract we've deployed for our DAO. Go and write contract, connect to Web3, and we're connected to the creator of the DAO who can count votes. And we go ahead and count the votes for proposal 1, write that. There's no error that will catch this contract interaction again, so we confirm, wait for that to go through. And now the votes for proposal 1 have been counted. And if we go and read our contract, look at proposal 1 over here, query that, we see that the count has been conducted true, and we get a pass date because there was a majority of votes up and actually no votes down, but we only had a voting turnout of 50%. So in this case, the DAO would go ahead and start setting up a burger joint. How cool is that? So now you have a basic idea of how this smart contract works for this DAO, and we can go ahead and start creating a front end to make it easier to facilitate the voting and casting proposals, not having to interact directly with the blockchain, but having a nice user interface that makes it more simple to use for the everyday user. So let's go ahead and get back to your IDE and start creating that front end. Rightio, so back in your favorite IDE, I use Visual Studio Code. I've set up this starter repository called DAO Start. You can clone this from the description below and then get going with me over here. And what you want to do is just run yarn to install all the dependencies we want. And at the same time over here, we can look at the project directory and you can see that we have an index.js file that takes a Moralis app ID and server URL. And these, of course, you can get from your Moralis servers. So create a new server on the Polygon Mumbai testnet, view the details, and get the application and server URL from here, and then paste them back into your index.js file. Then the app.js file is just a simple React app having 2 routes using React Router, the home page and a proposal page. So the home page will show us all the proposals, and then when we go onto the proposal route, we'll get an individual proposal and can vote on that and see the status of that. But that is basically it. So now if we just close this up and run yarn start, we should be able to go on localhost 3000 to see our project run in action. And beautiful, that is it. It is a beautiful white canvas, and I've set it up so that it will get this nice blue gradient after we start inputting some components in here. So let's get going in that app.js file and create a header for us. All right, close the console, and over here, start with the imports. We'll import from Web3 UI Kit, the connect button, and then we have an image folder from which we can import the Moralis logo. Voila. So now we have a Moralis logo item we can use as an image in the top left corner, and then we have the connect button from Web3 UI Kit we can use in the top right. And then just above our roots, so on every page we'll want to have the header, we'll just have it to be a div with a class name of header. Let's format this nicely. And then here on the left side, we'll have the Moralis logo, and then on the right side, we'll have the connect button. How easy is that? We save that, go check out our app. And boom, we have a Connect wallet and our Moralis logo over here. And let's just add a nice little tab list over here that will be a menu. In this starter project, we'll only fill out the DAO bit, but usually you'll have a forum or a documentation bit. So these are things that you can add later. But let's go ahead and add this tab list, and that comes from the Web3 UI Kit as well. It's so powerful, you need to start using it. Because we have everything set up in the header, we'll only want the menu on the home page. So we can go to our directory, search for pages, and go to home.js over here. And start by importing all the components we'll need from Web3 UI Kit, and it's quite a few in this project. So take a look at that and make sure you import all of these. And then now inside our content div over here, we can create our tab list, which has all the individual tabs within it. And that is done like so. So we have a tab list that is closed over here, and then within it we have 3 tabs, one for a DAO, one for a forum, one for docs. And we can start inputting information inside this DAO. But let's just go and see what this looks like. So if we save this page, go back to our app, we now have this beautiful header over here where we can go to the different pages. And on this DAO page, we want to start populating all the different proposals that have come through from our smart contract. And also, I think a nice little element would be some widget boxes over here that show a little bit of information about the DAO. How many proposals have been created overall, what the pass rate is, how many voters or NFT holders there are, and maybe an indication to how many ongoing proposals there are. So let's go ahead and create that first. So we have 3 different widgets here at the top of the page. Go over to your home.js file, and over here in your tab, create a div called tab content. And within this tab content, we'll give a title for the whole page called governance overview. And then we'll create this other div called widgets, in which we can import some of the Web3 UI Kit widgets with details about the ongoing processes within this DAO. Of course, by the end, when we have Moralis integrated, we'll get the actual data from the smart contract itself. But for now, we'll just hard code the details just to show you the UI effects. So without further rambling, let's just add the widgets over here. So we have 3 widgets. Let's format these nicely. One widget where we have info 52, and the title will be proposals created. So there'll be 52 proposals created. We give this a little bit of a larger width to kind of make it pop out. And then we have the eligible voters. Again, we've hard-coded 423, and then the ongoing proposals 5. And let's see what this looks like. If we save this, go to our page, and look at this. We get a nice little title, governance overview, proposals created 52, eligible voters 423, and ongoing proposals 5. But I think we can make this even slightly better. We could add the pass rate of our proposals over here because there's a lot of white space, and make a nice little progress bar with CSS to kind of represent that pass rate. So go back to your home.js file, and inside this first widget over here, let's create our pass rate component like so. So we have this div called extra widget information. It has a title called pass rate, and then we have this progress bar with then another div within it, which gives us the progress percentage, which we have hard coded to 60% over here. But this we can then get from our smart contract and Moralis to get actual pass rate of proposals when we have that integrated. And save this, go check out the page again. And this just makes this page look ever so much nicer. We have this pass rate and a 60% progress bar over here. And next, we can go ahead and create that table again with Web3 UI Kit because it's so powerful to show all the different proposals that have been created by our DAO members. Jumping back into our home.js file, we can go underneath this widgets div and create a new div. Let's scroll down a little bit. So we create this new div within it, which we have a table brought in from Web3 UI Kit, and the data should be in this variable called proposals. So we have to create this proposals variable at the top of our script, and the headers will be ID of the proposal, the description of the proposal, and the status, whether it's ongoing, rejected, or passed, and we give it a page size of 5, so we'll only show 5 proposals at any given time. And of course, we also give a title for it called recent proposals over here. So let's go ahead and create this proposals variable, and because we've already brought in useState, we can create it as a state variable over here. So now the state variable will be empty, but if we go check out your directory, you have this file called sampleproposals.js, where I've added an array of the format in which we will have our proposals stored when we actually integrate them from Moralis. So you can copy this for now and hard code it into our app for now. So if we go to home.js, in the useState, we can paste this in. Let's just format it nicely. So now your proposals variable will be an array of all the proposals. And as you'll see, it'll have the proposal number, the description of the proposal, and then a tag which presents whether it's passed, rejected, or ongoing. And of course, when we have Moralis, don't worry, we'll get the actual proposals from our smart contract. But for now, for the UI reasons, I just want to show you what it looks like. And you'll notice also here that we want to have the last tag to have a link to the proposals page using React Router, and then we can send state as well. Currently, the only state I'm sending when changing routes from the home page to the proposal page is just a simple string of hello, but when we actually do this, we can send state of the current proposal number, the proposal description, which will help us then present the correct data on the proposals page. So we have to import link from React Router to this app as well. Like so. So we have link brought in from React Router, and that will help us route to the proposals page from our table. So now we should be ready to save the page and go check out our app and see what it looks like. And wouldn't you guess it, our page is looking so beautiful. We have the governance overview, and then we have the most recent proposals. We have 5 proposals over here. Should we start a Moralis hamburger chain? Should we accept Elon Musk's 44 billion offer for our DAO? Of course, no. Our DAO is way stronger than $44 billion. And then we have 3 ongoing proposals over here. And then if you press the rejected over here, this takes us to the proposals route, which will help us when we go ahead and start creating this proposal page. But now let's go back to the DAO page. And the last thing that we have to add to this DAO page is submitting a new proposal for members of this DAO to start making votes on. So let's create that and create a Web3 UI kit form at the bottom of the page. Once again, let's go back to our home.js file. And now underneath our final div over here, so the div we have our table in, let's add our form from Web3 UI kit. You should have imported it already at the start, like so. So we have a form with a button which we set configurations to. So we'll just have the is loading state false. We can set this later on to when we press submit, it goes into loading state until the contract interaction for creating a proposal is complete. And then just basic information for the button, the loading text, the default text, and the theme will be secondary. Then the data, we'll just have it at 100% width, and the type here is important. We want a text area so we can type out our proposal, and we want validation required to be true, so we can't submit any empty proposals. And the initial value will be just empty, and on submit for now we'll just have an alert saying proposal submitted, but here we'll actually have a function to call our smart contract in the end, and the title for this form will be create a new proposal. And one last thing, if you'd like to make the page look a little neater, I added this little div over here at the bottom called voting. It just adds a cross section where the gradient changes to white, and I think it makes the page look a little nicer. So this div over here isn't mandatory. So we can go ahead and save the page and go back to our app. And so you see that cross section over here. And now when we scroll to the bottom, we have this create new proposal over here, which when we try and submit, it says, please fill in this field. So we can't submit an empty proposal. Then we can say yes or no, and then submit that. We get our alert proposal submitted, which later on will trigger our smart contract interaction for creating a proposal if we are a NFT holder. Okay, so that is the front end for our UI page. Remember, we went through this very quickly, but the final repo will also be available for you if you want to have a closer look, and you can always pause the video and go in your own pace. But now let's go on and move to this proposal page and create a nice UI for individual proposals where we see what the voting status is for an individual proposal, and what people have voted for this proposal already. And finally as well, your own smart contract interaction for voting on the proposal if you haven't done so already. So what we want to do is go over to our repo and go to this proposals.js file in your pages folder. Here, again, let's import first everything we need from Web3 UI Kit and the link that we'll use with React Router to allow us to route back to the home page if we'd like. And we'll actually start off with that. At the start of the page, when we come to the proposals page, we want to have a back button where we can return to the governance overview home page. So let's implement that first over here. Boom shakalaka. So we have a div called proposal in which we have a link tag that has a Web3 UI Kit icon with just a left arrow and then back to the overview page. And underneath we also have the title of this proposal page. This will be, of course, rendered to be the actual proposal we select in the future, but now we've just hard-coded it to be one of the proposals we have in our hard codes. So should we accept Elon Musk's 44 billion offer for our DAO? Let's save this and go see what this looks like. And look at this, beautiful. We have a link back to our overview page over here, and then we have the title of this proposal at the top. So if we press the overview, we're back at our home page. We can get back to our proposals page like this. Everything is working fantastically. Now what I want to add here is the status of this proposal. So whether it's ongoing, rejected, or passed, and then the proposer, because we can use the Web3 UI Kit's blocky component to get a nice blocky and the address of the user who's actually proposed this proposal. Here back in our proposal.js file, find this div where we have the hard-coded description of our proposal, and below that add a div called proposal overview where we'll have a tag that gives us a hard-coded red color and rejected for now. These will be automated in the future. And then we have a div which just has a span saying proposed by and then a blocky with any address you'd like for now, but this will be the proposer fetched from our smart contract. And then we also have a tooltip which the blocky is wrapped around so that when we hover over the blocky, we get a tooltip giving the address, not just the blocky, of the proposer's crypto wallet address. So now if we save this, go check out our page, and every time we come to this page, it just looks better and better. So we have our rejected and proposed by blocky with a tooltip giving the address of the proposer of this proposal. Now next, we of course want to have a similar widget view as on our overview page, but this time we'll want to have the votes up and votes down, and then we'll also have the percentage progress bars showing the amount of votes up versus the amount of votes down in percentages as well, giving the users a nice little indication on where this proposal is going if it's still going on. Now let's go add those widgets, and because it's exactly the same as we had in our home.js page, I'll just copy it out over here. Under this proposals div over here, let's add our widgets div like so, in which we have two widgets, one with 30 hard-coded votes up right now, giving us a 75% upvote percentage, and then 10 votes down, giving us a 25% downvote percentage. And this is the exact same functionality we had on the home.js page over here with our widgets and our percentage bars. So let's just go ahead and save this, head back to our page, and look at this. Our proposal page is starting to get its shine. We have our votes for, 30 votes for, and votes against 10, giving us the percentage of 75% votes up. So actually we would need to change these percentages in this hard code version, as this proposal was rejected, and in this case this proposal would have been approved as there were more votes up and more votes down. So let's just quickly change that. All right, that's a quick change. 10, 30, and 25% up, 75% down, save that. And now this is more realistic. This proposal that was rejected got 30 votes against and 10 votes for, making it rejected. And this is also good for when we have ongoing proposals. We can get the current voting status, so members of the DAO can have a perception of what the likelihood of a proposal going through is. Now, two last things we want to add here. One, because all the voting for the DAO is publicly available from the blockchain, we can read what the votes were for each member of the DAO. So everyone who's already voted, we can get their vote, whether they voted for or against. So we'll have a little table here having the address and then a nice little icon of a check mark or a down arrow, depending on what they voted. And then our last box will be for interacting with our smart contract. If we haven't yet voted for this proposal and we have a NFT that allows us to vote for it, we want to have a form here from Web3 UI Kit that allows us to vote for or against this proposal. So let's go ahead and implement those two last things. So back in our proposals.js file, go underneath this widgets div and we'll create our last div, which will be called a votes div, like so. And first we'll have only a table within it, but we'll also add that form later, because this will only have a width of 60%, and on its side we'll have the form to allow us to vote on this actual proposal. But for now, this table will only have two headers, an address and a vote, identifying the vote direction for this address. And the data you see is this votes variable, which we can again get a hard-coded sample set of data for our votes before we actually get the actual votes from our smart contract using Moralis. So let's go ahead and do that. Over here at the top, again, we have brought useState already. So we just make our state variable for votes, and you see it is an empty array, but in the repository, I provided you with a sample votes.js file in which you have this array of votes with an address and then a icon with either a check mark or a arrow circle down, which we can use as our sample hard-coded data. So we copy that, go back to our proposals, get this empty array and change it to our sample data. So now we have our actual votes, and we should be able to save this and go check out our Dapp. And would you look at that, looks beautiful. So we have these addresses and we get a identification of whether they voted for or against this proposal. And now the last thing, just that box allowing us to vote on this proposal if we haven't done so already. And as I've said a couple of times, it will just be a form from Web3 UI kit, which we can add. It'll be inside this div over here, like so. So a form, we'll have the width to be 35% as the table was 60%, leaving a nice little 5% gap between the two. And the button configuration, well, we won't have any loading state yet, but when we actually cast our votes and interact with our smart contract, we'll set it to loading while the smart contract interaction is going on. The theme is secondary. And for the data of this form, the most important part is that we'll have a radio button group where the options are for and against. So whether you want to vote for or against this proposal, and the validation, we have to provide either or, a for or against vote. And then on submit, currently we just get an alert saying vote cast, but here we will actually implement our smart contract voting functionality later on in the video. And that is about it for the UI bit. Again, here at the bottom, we can add a nice horizontal line, making the bottom of the page white, just adding a little stylistic feature. So go underneath the last div, add a div with a class name of voting. Again, this is completely optional. Just, I think it makes it look at the page a little bit better. So we save this, go to our page, and look at that. We have that nice little cut over there. And we have our addresses, and you can cast your vote for or against. So say we press against and submit, we get our alert saying vote cast, but here we'll have our smart contract functionality. But that completes our UI of the build. So we have a very sleek little decentralized autonomous organization UI where we can see all the proposals, some stats for the proposals, we can create a new proposal, and then pressing the status of a proposal, we go to the proposal page itself, see the status of a single vote, what people have been voting for this proposal, and you get a chance to vote on it yourself. Now, moving on to the next bit, which is going on to Moralis admin dashboard and syncing our smart contract events. So by syncing our smart contract events, we can get details from our smart contract to our Moralis database and then start presenting them over here with the actual data, votes for, the addresses that have voted, and then more importantly, for the overall DAO page, we get all the proposals and so on and so forth. So let's go ahead and jump into Moralis. Right, so after you find yourself in the Moralis admin dashboard and you have your DAO server that we created to get our app ID and server URL, you can view the details of your server and go to the sync tab in the top bar over here, and we can add a new sync event. Sync and watch contract events, like so. Make sure you check Polygon Mumbai. And then for the description, let's go look at our smart contract over here, which we have open in Visual Studio Code still. We had three events. We had the proposal created, new vote, and proposal count event. So the first event we want to sync is the proposal created event. So we'll give it a description, new proposal created, like so. And we'll want to sync our historical options as well, because we have already created one proposal at the start of the video. And then for the topic, this will be the event's name and the variables that it emits. So we can copy these from over here and paste it in over here. And what's important here, you take the event away and you just have the proposal created, the event name. And for the variables, you don't have the variable names, you just have the variable types. So uint256, string, uint256, and address. Then for the ABI, because luckily we have verified our smart contract and it's here on Polygon scan, we can go to the code over here and scroll to the bottom where you have the contract's application binary interface. And now we can search for proposal created event and then copy out this event section from over here. So it'll be this object to go back to your Moralis admin dashboard and paste it into the ABI section over here. Also here, the semicolon, we can remove that. And now, last thing, the address of the smart contract, which we have over here. In Polygon scan, we can copy that, paste it in the address. We won't need to filter our events, and as the table name, we'll have proposals. So now in our Moralis database, we should get a table with all the new proposals that have been created on our smart contract. We confirm, find that our new proposals created sync event has been created. We can close this and check out if it actually worked. Go to our dashboard. We have a proposals table, and in it we have one proposal with ID 1, max votes 4. If we scroll to the right, we get the proposer, and we should also have a description of the proposal. Yes, we do. Should we start a burger joint? If you remember, we did this earlier on in the video, so that's beautiful. Now let's go ahead and sync the last two events. So whenever a vote is cast, we have an event for that, and then whenever votes are counted, we have an event for that. So let's go back to our Moralis admin dashboard and go ahead and do those two sync events quickly, similarly to this. So we add new sync event, watch contract events, Polygon, description, vote cast. We'll sync historicals. The topic, again, we'll get from our smart contract. So new vote. Paste it in here, there and there, the event name and the variable types. Then for our contract API, paste that from our smart contract. Go to the new vote event, copy that from over here, back to our admin dashboard, paste our application binary interface, then our smart contract address, that's in there. And then the table name, we'll call this one votes. Let's confirm. And we have our vote cast sync event done. Now for the last sync event, add a new sync event, sync and watch contract events, Polygon Mumbai, description, count votes, like so, sync historical because we have counted votes once already. Then the topic from our smart contract, this is a simple proposal count. We only have the uint and the Boolean if it passed. Paste that into the topic, that's in there, proposal count. Then for the contract ABI, go back to our ABI once more, find our proposal count event from here, very short this time, copy that back into our admin dashboard, paste it in there, then the contract address, again paste it in here, then scrolling down to the bottom and calling a table name, we can give this a table name of proposal counts and confirm. Now we have 3 sync and watch contract events on our Moralis server that are looking at our DAO smart contract and pulling the data into our Moralis database. So if we close this, look at our dashboard, we already looked at our proposals, but if we look at our votes, we had 2 votes, we had the voters, and we had there both voting up. So at the latest vote had 2 votes up. And if we look at the voted for key, we get true for both of them. Then for the proposal counts, we've already conducted 1 proposal count, and it was passed true for proposal 1 over here. So now we have all this beautiful data in our Moralis database, and we can start pulling this into our DAO front end. And then finally, after that, we can create our executing smart contract functionality to integrate with our front end to be able to add rows into these tables from our front end, which will be super cool. So let's get back into our front end. Rightio, so all this data that we have on our DAO's front page of the status of our DAO, we can actually get from the tables we have in Moralis, for the exception of this eligible voters, which we'll have to use the Moralis Web3 API for to get the holders of the NFTs. That gives you access to this DAO. So let's go ahead and start cracking with building this by jumping back into our front end repository and going to the home.js file, in which we can start by bringing in use Moralis from React Moralis, which allows us to access our Moralis database. Now let's create a few state variables in which we can store all the information that we then eventually get from our database, like so. So see, we initialize all of them to 0. We get the pass rate, the total proposal created, and the total proposals counted. And then from use Moralis, we destructure Moralis and it is initialized. Moralis we'll use to interact with our database, and is initialized, we'll just check if Moralis is initialized with our Dapp, allowing us to access our Moralis database. Now we can also get rid of these hard-coded proposals, as we will be creating them ourselves now, like so. And let's go ahead and start by creating one function to get the status of a proposal. So we'll be looking into the proposal counts data table and see if a proposal ID is within this data table, and that will basically allow us to generate if a proposal is an ongoing state, past state, or rejected state. All right, so let's give it a little space and create that function over here. Rightio, so an asynchronous function where we get the status of a proposal ID. We'll start it by extending our proposals count Moralis data table and then creating a query for this data table. Then we'll make sure that in our query, the UID column is equal to the proposal ID we set at the function call. And then we only search for the first match as it is a unique identifier for the proposals. And then finally, we can create this conditional statement where we see if the results of our query are not undefined, we know that in the attributes there will be the past column. If the past state is true, then we return an object with color green and a text called past. We'll use this object then to render our tag with the correct color and text. And otherwise, if the past state is false, then we'll return an object with color red and text rejected. Now, if the result of our query is undefined, so there's no matching entries in our data table, then that means that the proposal has not been counted yet and it will be ongoing and will return an object with color blue and text ongoing. Now this function will just help us to get that right tag for each proposal. And now we can go ahead and start querying for all the proposals. So for this, let's create a use effect that is run every time we get a Moralis is initialized state change. So whenever Moralis is initialized, we'll go ahead and go get our proposals from our Moralis database. And it'll be a very similar procedure as to here getting our proposal counts. First, we create this asynchronous function to get our proposals. Then we extend the proposals table from Moralis and query this proposals table. We make sure that our query is in descending order of our proposals in decimal format, so we get the latest proposal first, as the more historic proposals will most likely already be voted on. And then the results we can await and get all the different proposals that we have in our Moralis database. This will help us to populate our table. Now here's the interesting bit. Because in our table, we want, of course, the proposal ID and the description, which we have in the Moralis data table, but we don't have the state of whether it's rejected, ongoing, or past, and that's where we can use this getStatus function and create that tag that's wrapped around a link to the proposals page. So what we do is we do this promise all where we map through all the results we have, we get each one's proposal ID, description, and then we create a link to the proposals page, as I said, and we pass in as state so the proposal route knows which description of the proposal we have. Then using the getStatus function, we get the color of the tag of the current status of our proposal and then the text, whether it's be ongoing, past, or rejected. And then we also pass it the proposal ID and whoever proposed this proposal. And then in the tag itself on our home page, we also want to get the color of the tag and the text of the tag so we can present this in the table. It's a mouthful, but you'll see what's going on very shortly here. Now that we've got all the proposals and the data for our table, we can just set these to our state variables over here. So we have this proposal state will be this table that we previously had hard-coded. Now we've generated it in our use effect hook over here. And then we've set the total proposals to the length of results array that we got from our initial query over here. But now let's create one more function to get our pass rate and help us render this progress bar over here. So let me just paste that in here and talk you through it. So getPassRate is the name of the asynchronous function. Again, we're extending the proposals count Moralis data table, and we're just getting all the proposals that have been counted on. We initialize a votes up counter and loop through all of our results array, checking whether the proposal was passed. And if it was, we increment the votes up by 1. And now we can set the state of all the counted proposals to counted, and then we can set the pass rate to all the votes up that were incremented divided by our results length and multiply that by 100. That will give our pass rate for our DAO's proposals. Now, of course, in our use effect, because we've only initialized these functions, getPassRate and getProposals, we also need to run them at the bottom of our use effect. So we can just chuck them down here. And now what we want to do is use these state variables in our actual rendering of our widgets. So we go to our widget section over here, and let's change out all these hard-coded values. So for proposals created will be total P. Our Pass rate will be pass rate. Our eligible voters will still have to implement this using the Moralis Web3 API, so we don't have that yet. But our ongoing proposals will be our total proposals minus our counted proposals. And then our table is already set to proposals, but we have to do one thing. So our DAO, we want to make sure that it only renders if we have the proposals. Because if we don't have it, React won't like it. So let's make this conditional proposals and close this out at the bottom of our tab over here. Like so. So this will just make sure that before we actually render anything, our proposals will be undefined, so it won't render anything, but after we go through this use effect, we'll start rendering. But now, if we save this and go check out our app, it should be rendering with the data from our smart contract already. And look at how cool this is. We have our should we start a burger joint proposal, and it was passed. We have our total proposals created, which was 1. The pass rate is 100%. The eligible voters is still not implemented. We have to implement that next. And the ongoing proposals, because we haven't presented any more proposals, that is set to 0. How cool is this? And then this will automatically be updated as we interact with our smart contract. You're doing great so far. Let's just implement this eligible voters with the Moralis Web3 API, and then we can move on to getting the actual figures for our proposal page as well. Now for this, we'll want to import from React Moralis, use Moralis Web3 API call as well, use Moralis Web3 API, and we'll call it just Web3 API for simplicity's sake. And now, underneath getPassRate function, we can write one more function to use the Moralis Web3 API, like so. So we create this function called fetchTokenIDOwners, which is again an asynchronous function, and we provide a few options. We look at the Polygon Mumbai testnet OpenSea storefront contract, and we look for the token ID with this number. This is the token ID that gives access to our DAO, also present in our smart contract. And again, we have to provide the chain we are looking at, so the Mumbai testnet chain. And then just calling the Web3 API token parameter, we get the token ID owners by providing these options. And then for the addresses, whatever the variable token ID owners returns us will have a result, and we can map through all the elements within the results and get the owner of, which is the address of this NFT token. And then we just set our voters state variable to these addresses. And now we can use this voters state variable to get the length, and that way get the eligible voters. So let's go down to our widgets over here where we have 423. Let's rather write voters.length. And then we also have to create that state variable. We forgot to do that at the start. So over here, let's create a const voters, set voters, and initial state. We can say 0 as well. And now that is how easy it is to use the Moralis Web3 API to get the addresses of the owners of any NFT of your choosing. And for us, because we're interested in this NFT token that gives access to our DAO, we're using this token ID. So let's save that. And one last thing I forgot, we of course have to call this fetch token ID owners. So let's add that over here. Fetch token ID owners with our get proposals and get pass rate function as well. Save that, and now go check out our app, and look at that. We have our 4 eligible voters because there are four holders of our NFTs like we saw in OpenSea over here. Now back in our app, we're now going to be concerned about creating this proposal page where we use a similar method to get the votes for, the votes against, and the votes of different addresses that are eligible to vote. And then after that, we can go ahead and start creating execute smart contract functionality for this cast vote section, and then our create new proposal section. But for now, let's go ahead and fill these out with details for the correct proposal that was clicked on the overview page. Starting off, we can get some low-hanging fruit by going to the proposals.js file over here and bringing in useLocation from React Router. With useLocation, we can now then get the state that we send when coming from the overview page to this proposal route and store it in this proposal details variable, which will be then an object that has all this data for description, the color, text, ID, and proposer, and we can fill these out in our proposals page over here. So let's start by doing that because this is just an easy win for us. Rightio, so rather than having a hard-coded description, we can get the description from the proposal details like so. Then for the color and the text, we can do that as well. Get the color and text. Boom shakalaka. And then for the tooltip, for the address of the proposer and then the blocky image, we can also get the proposer from proposal details, add them over here like so. And now, wouldn't you know it, if we save this, go to our page, we've already got some information over here. So should we start our burger joint? It was passed, and then we get the proposed by, and this is the correct address who proposed this should we start a burger joint proposal. Anyways, a massive quick win just by using the proposal details. Now for querying our Moralis database for the votes for and votes against and rendering these two widgets with the correct information. Let's kick things off by importing use Moralis again at the top of our file, use Moralis, and then we can, rather than having this predefined votes array, we can create all our state variables that we'll need, like so. So again, we get Moralis so we can interact with our database. We check if Moralis is initialized. We have a variable for the latest vote, the percentage up, the percentage down, and then the votes array, which will allow us to render the table to see what different addresses have voted. And now let's just create a use effect like we did on our home.js page to query our Moralis database. So again, we can start by creating this use effect that is only run when Moralis is initialized. And then we create an asynchronous function called getVotes and then call that getVotes functionality. But the interesting bit is what goes inside this asynchronous function. So starting off, we of course need to query the Moralis database for votes. And what we do is we make sure that the proposal column is equal to the ID we get when coming to this proposal state from the state. So whichever proposal we click on the overview page, we query for that proposal in the Moralis database and get all the votes in descending order. This will help us when we present all the votes. So we get a descending order of the most recent votes. And then we just get all of the votes for that specific proposal. Now for a slightly longer conditional, because if the results returns as an array, so we have votes for the specific proposal, we'll set the latest vote to the first element within the results array and the attributes of that. So that will give us the current status of votes up and votes down as that is emitted from our smart contract. And then for the percentage down, we can just calculate from the latest vote event the number of votes down divided by the total amount of votes multiplied by 100, and then we get a fixed whole number. And then the same thing for percentage up, we get the votes, the current votes up from the latest vote as that is emitted from the smart contract, and we divide that by all the votes and multiply by 100. Now, one last thing we do in this function is we want to get an array of all the addresses that have voted, which will be in this results array, but we also want to get the direction in which they have voted and store the icon. So we create this variable that maps through our results array. It gets the voter, stores that as the first element of the array, and in the second element of the array, it gets an icon with fill color green if the voted for was true, and if they voted against, so the voted for parameter would be false, it would be red, and then the SVG, so the icon will be a check mark for votes for and a arrow circle down for votes against. And then we just set our votes state variable to this votes direction array that we calculated over here. And that should have us set if we go ahead and save that, and also go ahead and conditionally render our widgets div over here. So as long as we have latest vote, we render our widgets div like so. So that means that we'll only get the votes for and against if there is a latest vote. If there's no latest vote, we won't get those two widgets. So now save and go check out our page. All right, beautiful. So we have the votes over here. So two people voted and they both voted for, so we have a green check mark, but we didn't actually implement our state variables for these widgets. So let's go and implement those now. Here in our first widget, the info will be our latest vote, votes up, and the same thing for the votes against, but in this case, it will be votes down. And then the percentages will be pers up, put them in both of these places where we've hard-coded them, and then for the percentage down, we use percentage down, like so. And if I'm not mistaken, that might have us ready. Save that, go back, and that worked perfectly. So we had two votes, and both were for, so we have a 100% rate of votes for and a 0% rate of votes against. And now our UI is ready with all of our smart contract details. So we're pulling all the details from our smart contract and through Moralis to present it on our DAO front end. And now we can go ahead and start creating a smart contract execute functionality for casting votes and creating a new proposal. But let's do create new proposals first. So head over to your home.js file. Find home.js over here and scroll over to the top of the file, and we'll have to import from React Moralis, use Web3 execute function, use Web3 execute function like so, and then we can call it just contract processor, and we'll also create a state variable called sub, which will be a true or false Boolean depending on whether we are submitting our proposal, and it'll show a loading state in our button. But now we have this contract processor, and we can go ahead and start creating a function. So it'll once again be a asynchronous function called create proposal, and it'll take one parameter, the new proposal description. And let's start by setting up some options we need to provide for our contract processor. So the contract address we can get again from Polygon scan where our verified smart contract exists. So we copy this address, paste it into our contract address. The function name, let's just go and check what the function name was. So here on Polygon scan, we of course have our complete smart contract, and it was create proposal. Create proposal is the function name. And just for reference already, we have two parameters. This takes a underscore description and a underscore can vote. So the function name was create proposal. The contract API, let's get that from our Polygon scan again. So we find it's over here, create proposals, but let's just get the function bit from over here. It starts from the inputs. So copy that, head over to your ABI and paste the application binary interface for creating a proposal. And like I said, the description and the can vote are the two parameters this takes. So in our case, whatever we call when calling the create proposal as the new proposal, we set as the description when calling our smart contract. And then the can vote is the voters array we use the Web3 API to get earlier on over here. So we have this fetch token ID owners where we set the voters to be the addresses of holders of this NFT token we have decided to be the premise of our DAO membership. Now with that complete, we only have to await our contract processor to run through, scroll down a bit, and await our contract processor to fetch parameters using our options that we set above over here. And if it's successful, we console log the proposal was successful, and we set submit state to false because we're not submitting our contract interaction anymore. And if there's an error, we again alert the user on what the error was. And most likely the reason for this error will be that they don't hold an NFT token and can't actually create a proposal on this DAO. And of course, we also set the submitting state of our contract interaction to false here as well. Save this, and now in our form at the bottom of the page, we have to go ahead and trigger this create proposal function. Scroll down to your form over here, and first of course we can set the loading state to sub, and our onSubmit event for our form we can now change to first setting our submit state to true, so our contract process will start loading, and we run this create proposal function, which is a call to our smart contract with the data from our form, and the data can be accessed from the data array from our form. And because we only have one input, we have the text area input, it will be the first element and it'll be the input result. So the text in the text area will be set as the description of our proposal. So now we should be set to go to create a proposal. Let's go try it out, save this and go to our page. Make sure that we are connected with our Web3 wallet. So account 1, this is the smart contract creator, and it actually holds one of the NFTs, so they should be able to create a proposal. We try and create a proposal. Should we make a Web3 medium clone? And then press submit. MetaMask pops us, asks us, do we want to make this contract interaction? We confirm. The contract interaction is in process, and it was successfully submitted. Now, if we refresh this page, look at this, we get a proposal ID 2, should we make a Web3 medium clone, and it is ongoing. I'll show you in the smart contract on Polygon scan as well. If we go look at the events, we have a new event just come through 42 seconds ago, create proposal, and it has all the details. They're hex encoded, so it's hard to tell, but see here, if we change this to text, should we make a Web3 Medium clone? So how cool is that? That data is also in our Moralis database. So if we refresh this, go check out our proposals. Now we have a second proposal over here, and it is the should we make a Medium Web3 clone. Now heading back to our app, we can actually go to the proposal page. But now we see that because we haven't actually cast any votes, we won't have the status of the voting, and there are no votes. There's no data for addresses of the votes, and we can't cast the vote yet because we haven't implemented that functionality, but let's go ahead and do that next. Right, so similar to our home.js file, let's go to proposals.js and import use web3 execute function, and the state variable for submit state, and our contract processor, which is our use web3 execute function. And now we can go ahead and create a new function here, cast vote, and this will only take one parameter, whether we want to vote up or down. And again, it will be triggered when we submit our Web3 UI kit form. And here, let's do the same thing, provide the options like so. So our contract address is still the same, but this time we're calling the vote on proposal function, and its contract ABI is this. You can get it the same method we did for our create proposal function. And then the parameters for this function were the ID of the proposal we want to vote on, and then your vote, true for voting for and false for voting against. So from the state, we get the proposal details ID, so we know which proposal we're voting on. And then currently we're set to voting always true, but we can change this to vote up down, which is what we call in our cast vote function call. So now whatever we call in our cast vote function will be set to our vote when we vote on a proposal. Now, waiting for our contract processor to run, the exact same as on our last page. We just await for our contract processor to fetch using the options we provided over here. And then on success, we console log that the vote was cast successfully. But then if there's an error, like you've already voted or you can't vote on a proposal, then that will be alerted to the user. Now going down to our form and actually triggering this cast vote functionality, we can first make the form disabled if the proposal we're on is not ongoing. So if it's already rejected or passed, we won't allow the users to vote on it again, just to avoid any confusion. Then the isLoading state will again change to sub, and then our onSubmit will just take our current alert away from here and have a conditional on checking whether our radio input has been set to 4, we'll cast our vote to be true, and if it's set to against, we'll cast our vote to be false. And we'll set our submitting state to true, so you can't press the submit button multiple times, and that should have us done for our casting vote functionality. Save that, and now going to our page, I believe our voting for this proposal will not be available anymore because we're past the deadline, but we can try it if we submit. Yeah, we get an error, deadline has passed for this proposal. Okay, so let's go back to our overview page over here and create a new proposal. So let's say hypothetically we wanted to create that proposal asking, should we accept Elon Musk's 44 billion offer for our DAO? We can submit that. It will be created as a proposal. We confirm. Scroll up over here, look at our MetaMask, our contract interactions pending. And now that it's gone through, we can refresh the page and we should have a third proposal over here that's ongoing. We press that. We can vote for it now, submit. MetaMask asks us, do we want to vote for this proposal? We confirm. We voted for because this is our own proposal. Otherwise, we definitely wouldn't sell our DAO for 44 billion. Perfect. Our contract interaction went through. Refresh the page. And look at that. We have one vote for, and it is our address. Now let's see if we change our account. So open up MetaMask. Go to account 5 over here, which doesn't hold this NFT. Let's connect this account and connect our wallet. MetaMask. Account 5 over here. Sign. Now if we try and vote for on this, should we accept Elon Musk's 44 billion offer? Submit. We get an error. You cannot vote on this proposal because we don't hold that NFT. Okay, now let's go on a different account. Account 3 does have this NFT, so we connect that wallet, MetaMask, sign. So this account should have this NFT, so we can submit our vote against, submit. MetaMask pops us, allows us to vote on this. We confirm. That's gone through. Now we refresh the page and look at that, 0x4C. So the currently logged in account voted against and our vote percentage is 50-50 at the moment. Again here, now this proposal that we can't vote anymore, the deadline is passed. Now the contract owner can go over to Polygon Scan, go to the contract, write the contract, and let's connect to Web3 first on account 1, who is the owner of the smart contract, connect to Web3, and let's count the votes for proposal 2, right? And because there was no votes, this should be a rejected transaction. That's counted. So now if we go back to our DAO, on the overview page, refresh this page, look at that, this state changed to rejected. And if we go there, our cast vote ability is disabled because this has already concluded voting. It actually got no votes, so it wasn't passed. And we can still vote on this third proposal. So everyone who has the NFT that allows voting in this DAO can still go ahead and vote on this proposal. So that's the complete build. You see that our proposals created has been incremented to 3. The pass rate is 50% because we have 1 passed and 1 rejected vote. Then we have 1 ongoing proposal over here. We can press that. We can see how people have voted for it. If we have NFT, we can even vote for this proposal ourselves. How cool is that? You can create your own DAO using a little bit of Solidity knowledge and integrating it with Moralis and creating this beautiful DAO. Hopefully you enjoy this video. I can't wait to see your builds. And if you're really excited, what you can actually do is go ahead and use the Moralis Builder NFTs to create a DAO for yourself, for Moralis builders. So that's a little bit of extra credit for anyone who's really into this and can go ahead and go to OpenSea and use this Moralis Hall of Fame NFT collection to create this DAO. That would be so cool. So that's just a little idea for you if anyone's looking for a project of their own. Now with that said, hopefully you enjoy this project and you build Moralis project in the future again. I'll see you in the next one.